All right, guys. So we have been dealing on this is like a video now. So this is another series on basics of C, like all you need to know about C before you start writing the codes. So the person that will be talking now is Mr. Gafar, explaining all about C, the history about C, and so on like that. So I've helped you to timestamp some of the spaces where he started the history, where he started writing codes, and so on like that. So you can check somewhere around this video. Just go to the description section or the comment section. You will see transcript. Just check the transcript so that you can check where you need.
Okay, thank you. Uh-huh. All right. So now this is the main file here now, as you can see. If I have another file I want to create, you understand, then I will create it inside it. Even if I have 10, you will see them lining down, like you will see them lining up here. Are we getting it? Now, this file has been created for me. Are we getting it? Automatically. So if I run this, so look at it, for you to run your file, C++ use something we call what? Compiler. You understand? To convert all this thing that has been written in English language, to convert them then from low level language words to machine language. Then once machine understand, it's going to send back the feedback. So you don't need to, if I should click on run, there is high probability that this program is not going to run. Are you getting it? And anytime you make a change, let's say I try to modify this now, let me run this. You see, it's building. This is hello world. Let me press enter. Now let me come here and add hello world to ALX students. Now let me run it. You see it? It's still showing me what? Hello world. For the fact that I've added some text here, as you can see. For the fact that I've added some text, I click on run, it's going to run. But it's going to be, why is it doing this? It's doing this because of what? Of the previous say. That is why most of you, when you do something on your sandbox, and you still be asking questions, after doing this, do I need to push it? You modify a file. Anytime you modify, you add, you delete, you need to push that code. Are you getting in? So that your the system, your program will understand that there is a modification. Modification can be anything. Are you getting it? Okay, now look at my return statement. My return statement, I don't have something like this, and I don't have something like this, and it's still working. But why in our sandbox, if I do something like this, it's not going to run? Because that is the styling ALS has chosen. You understand? Just to make you a better programmer. Are we getting it? Now, why is this thing not running? Because I have to recompile it again to tell the program that, okay, the compiler that, yes, I've made a modification, so I need to redo it, I need to recompile it for me so that everything will now come balanced. Now, if I recompile, let me do it again, let me rerun. You can see it's not displaying. Now, if I show, you can see build, it's showing build and run, or you can just come here. You can see build, compile current file, run alone, or you can press F9 to do what? To build and what? Run. You can press Control and what? F11 to rebuild the whole project. So let's say you have tons of files, you have almost 18 files. You've made modification in most of them, let's say like in 12. You need to rebuild that file before it's going to do what it's going to work. So if I rebuild it, you can see now it's not showing ALX students, because I noticed that somebody was telling me that they make modification and the person did not build. The person was only clicking on run, and is getting the same results. Yes, you're going to get the same results. Now, let's explain what all this means from line 1 to what? Line 9 or line 8. Anyone? This line, it means we need to include a header file. You understand? Since we have a library already. Understand? Or let's include a library. That's how you guys understood it. Let's go back to our notes here. Okay, let's go back to our notes here. As you can see, this is the program here. I've not done any miracle. There's nothing. So let's say they are trying to explain to us, what does this mean? This include STHIOD. This STH stand for what? Standard. I is for what? Input. YO is for what? Output. You can see it's a library function. The print function is defined in stdio.h. Now, yesterday I was making reference. I was telling you guys that in function, we have two types of function. Number one is the building function, while number two is what? The user-defined function. Now, let's say, for example, maybe this program, maybe they are lying, we don't know, but let's remove this file. Then let's try and build this program and run it. Is it working? Fine, good. Now, let's remove this standard library. Let's remove it. Then let's try and run our code. Let's see if it's going to work. Our code is running, but why is it running? Now, I'm going to explain why. The reason why it's working is that when they first built this programming language, you understand? When they first built the language, just like when they first built our first generation of computer, second generation of computer. Now, I'm going to use computer to explain first before I come back to this. When we first build our first generation of computer, what it means is that there is a keyboard, there is a mouse, you understand, and there is system units, and there is monitor. It means that all these devices must be connected together before you can on your system. Now, let's say you did not plug your keyboard and your mouse. Immediately you power on the computer is not going to boot, but it's going to show you an error telling you that there is no keyboard and there is no what? There is no mouse. That is why it's not going to work. Are we getting it? So until you do what? You plug them in before you do not do what? It will not actually work. Are we getting it? So the same thing when they first build all this language, it's not only C++. Even like Fortran, it's not only C language. Even Fortran, C++, Java, some programming language like that, they have the same thing. You understand? They build them almost the same way. But as time goes on, we are now in 2021. Imagine a program that has been developed since more than before 1990. So are you saying that they are going to stick to that features? No. So that means there is a new update. So now whether you include that library or you do not include it, doesn't mean that your program is not going to run. You understand? But it is very paramount that you include it because of other function. This standard H alone, this standard input output .h, this library alone contains more than, I can't tell you how many functions you contain, but they are very many, very, very plenty. You understand it? So let's go back. So let's put this. So this, the STD means what? Standard. Means standard. While the I mean, what are they calling it? Let me comment this one too. Mean input from the keyboard. Why the O mean outputs to the what? To the screen. That is what it means. As you can see, this one is just standard LIB, mean library. This one is just standard libraries. Are we getting it? Now, in main, you might see all this one, but actually, where did your program started running? Your program started running at what? At line 7. Forget about whatever you see here. Your program started running at line 7. This is what we call it. What? This is what? The main function. The main function that contains, it must be contained in every. Can you zoom your screen? Exactly. That's what I want to say. Please, can you zoom your screen? In every program. So I'm not using any screen.
You guys the screen of zoom in from your own end. Try zooming in from your own end.
Okay, me, right?
No, no need. Continue.
Okay, yes, please, if you are using phone and you cannot see, just zoom on your screen and you're going to see it clearly. Yes, please. Sorry. So, as you can see, this is our main function. It means that this is where our program is going to start. Now, let me show you something. If I should do something like this, understand? Then I have a function here that let's say void my age, you understand? Then I open this, you understand? I don't want to display anything for now, so I can leave it. Then I can create this, you understand? Then I go something like this. Then I say print F. Okay, I do this something like this, and I say my. Let's say I am 28 years old. Are we getting it? Let us say something like this. I just did something like this. Then I close it. Now, the funny thing is this, and I want you guys to see it. I'm going to run this program, and you are going to see that this program is not good. This one, from line 7 to line 9, is not going to display. Let's try it. Do you see it? What I'm still getting is what? Hello world to what? To ALX students. This, we call it what? This is called a user defined function, because I'm the one that defined it. But it doesn't mean, but this one is ahead of this one. So which means this program is not going, even if I have them more than 500 years, they are not going to run, because this is where the program is supposed to start. It doesn't matter where is it, whether it's in line 200 or like 1 million. This is the first thing that is going to run, and is the one that is going to control every other thing. Are we getting it? Now I know you guys might want to ask questions that but wait, from all the projects we have been doing, like function and nested, we did debugging, we did that. We don't have this main function. We only created 2 files. We create main.h file where we include all the prototype file, all the prototype function. Then in our main program here, we put what is only void something or in something. Then we test the program, it run. you are correct. But again, you are not correct because there is one thing missing. There is a third file. The name of that third file is called main.c. So according to instruction from what? From ALX, that we are not to create it. Because if we are told to create it, you will see the int, you will see this one there. We always see it there. It must be there. But then they say we should not create it. They already have it. So they are going to use it. They are going to use this main.c. They are going to use it to test your own, then test it with what? Main.h to see if there is a correlation between them and they are related together. So which means they are working together. Okay? So a lot of you will say, my code is actually correct. And I've embedded the words. I have included the function prototype in the main.h. But why is my code is not working? The problem might be in your main.function, your main.c, the one that ALX hided from us, you understand? The one that they hided from us, that they only keep it to themselves, and they use it to justify our program, and they contain all this. Maybe there is a way they want you to do it. That's why you see they will be telling that indentation, all that, this and that. If you have something that includes, now if I have something like this, means even if I run this program and I did not include this, it's not going to work. I don't know if you are getting it. It's not going to work because I include a parameter. So which means this function will be expecting that this defined function, this one, let me put it here. This one is what? This one is call it built-in function. This function, you cannot change it. We're going to say beginning of every C program. But this is the beginning. Are we getting it? Are we getting it? Then our programs end here. End of what? Of the program. This is where our programs ends. So let me expand this. Now there's another thing I want us to know. We have this our main function. We start it with what? With integer. This means something. What does this mean? It means that we want it to return something. We want a return type. And the return type is what? Is integer. That is why we always have return 0. Are we getting it? If I change this one, if I change it to what? To void, it means that we want our main program to return, but we don't want it to return any type. Understand? So it's not going to return anything, which means anytime you are using void, this void, it means that you just want to print something out. You don't want anything. You don't want any return type, whether it is floating, whether it is integer, whether it is, you don't want anything like that. Are we getting it? But we always use int to indicate that we are returning something. Now this printf, it means to display. You can see you can actually comment anywhere on your code. Are we getting it? You can comment, but the problem is that you cannot comment from here. It's going to, you see, it has comment that line out. You can't do that from here. So, but you can do it from here. You can do something like to display any content inside a function. Printf itself, this as you are saying it, is what? Is a function, as you can see. It's also a function on its own. Are we getting it? Yeah, so this is our program. Now, if I want this to run, what will I do? I'm going to call the name of this function. Let's say, for instance, now if I call it here, let's try something. I just say my age. Let's run this. You see, it's telling me that I cannot run this. I don't know whether you guys are saying it. It's telling me that there is a problem. During the compilation process, it's telling me that there is a problem here. Why? Because it's below our return. So you should always have it in mind that this return statement will be what? Will be the only thing that will always end your program. And for everything, for every statement in C language, we always end it with what? With semicolon. It's very, very important. Now I can remove this here, then I can put it here. Now I want to show you guys something. I can put it here. Now if I try to run it and build it, it's going to complain. What is it complaining? It's complaining that I don't have this. Let's run it again and build it. Now it's complaining of something. What is it complaining? Anybody can have any guess? It's complaining because I have int a. So which means it's accepting, it's waiting for what? An integer value. So let's say I try, let's say I put something like 30. Let's run it and build it. Now do you see it? It's showing me what now? I am 28 years old. Now this is now, it will now run now. Why? Because we invoke it, we call the function name. Are we getting it? Now, but there's another thing. If you look at it, you notice that my printf is actually here. So you'll be expecting that my age is supposed to be somewhere here or somewhere here. It doesn't matter where I put it. The only reason why ALX is telling you to indent your code is because they want you to master the art of how to actually do what? Write a neat code. You understand? It's not only going to be, it's not only going to, it's not as if maybe they are stressing you. It's going to be beneficial to you and to what? To other people. Now, let's say me and you, let's say like 5 of us now, we are collaborating on a project. Understand? And we'll be pushing our code. Now, from here, imagine that I'm putting everything on the same line. Because I can actually do this. I can run it here. Okay, let me remove this. But we are going to see whether it's going to work or not. Let's try it. You can see I have them on the same line. Let's run it. Do you see that my program is actually working? Yes, it's going to work. Because the compiler understands that immediately you put this semicolon, it means that this is a statement. You also understand that this is a statement, which means they are not the same thing. This is also what? A statement. So it's going to execute everything. In fact, we can decide to remove this too. But you guys, I'm just trying to show you that the reason why ALS is making it that way, you can see, even if I put it this way and I put this curly brace and I put it here, your program is still going to run. It's going to work. But now, let's say you are writing a program that have more than 100 or 50, 150 line of code. Imagine you are writing them in a single line. Or you are just writing, you put this on here, you don't intend it, you know, it's scatter your work. Number one, even you yourself, the second day you open that code, you feel very disgusted at what the hell is this? Who do this? When exactly did I write this code? Now, if you send it to me, I will be like, what are you doing? Please, I can't do anything with this code. Please, make sure you indent your code very well. Indentation, you can do it the way you want. But for ALS to tell us to use Betista, that means there is a way they want you guys to do it, not you guys to do it. That is why it's being instructed that way. Are we getting it? All right. Please, if there's any question we can ask, but for now, I'm going to delete this because we're not going to be talking about this for now. We just want us to know the concepts behind all this. Are we getting it? So let's go straight next to works. So we've explained everything that is here, and they show us how to actually print. This one is using they're using Turbo. So if you don't see C++, you can actually do that. For the evaluation we did yesterday, they asked a particular question. How did we? I can't remember the name of the question, but the answer is pre-processing, compilation, this, then and linking. Compiler and linking, right? This is exactly what is happening. Now, look at this. This is the code you are writing where in your C++, the program, or in your C language. This is exactly what you have done. But I told you the computer is not going to understand. It's going to translate. You see, this is exactly what the computer understands. 010000000. If you are to write this program like this, do you think you'll be able to do it? No. Let's assume that up to date in 2022, let's assume that every language we have, we can't use human readable language. We can't use English language or Chinese or any language. This is the only thing we are using 0 and 1. I'm telling you now, everybody will rather become a lawyer or become something else. Nobody wants to do mathematics. Nobody will come to this field. Because you cannot be using all your time to be saying 0, 1, 0, 0, 0, 0, 0, 0. Because the scientists themselves, the people that build all these compiler, all these things, is because they cannot keep up. Now, let me tell you how difficult they find it. Imagine that somebody wants to add 2 plus 2. This is exactly what they are going to be writing. You understand? And it's taking them a lot of time to solve problems. So they decided to do what? To see how they can actually create a human language and find a ways to create a relationship between what? Because anything you write in English language, we actually call it high-level language. Anything that is like this, we call it what? We call it machine language. But this is not a low-level language. A low-level language is somehow close to human language, and is somehow close to the machine language. Is the intermediary between them. You understand? Let's say I want to add 2 numbers in low-level language. In fact, it will not make sense. Even if I type it to you guys will not understand it. Yes, I think I have idea on low-level language because I'm using it. You understand? It will not make any sense. Even this one does not make any sense. But the fact that I know binary doesn't mean that I understand it. But this is the only thing I understand. And if you check almost every developer, this is what they can do. They cannot do this. But this is what is just somehow complicated. So what are the compilation process in C? We have what? Compilation. What is compilation? We say it's a process of converting the source code. We call this one another thing. You can call this one source code. But this is actually the source. Then this is what? Object code. It can be converted. This compilation can convert from yikes. I'm sorry. Okay. I'm having less than, let me see, my battery is very, very low now, which is 10%. It can go down anytime. Please, I'm very sorry for this. So let me just explain this. This is what? This is a source code. Why this is object code? So your compiler have the ability to convert from source code to what? to object code. And after compiling it, it can compile it back from what? From object code back to what? To source code. Why is it doing all this? It's doing it to check if there is error. It's just like when you are making phone call, you understand? Or when you send a text message. A lot of you must have noticed this, but let me explain. Sometimes somebody will send a message to you on WhatsApp, or a normal text message, you will send it to somebody, or somebody will send it to you. You see that you see the part of the message, but it's telling you that the remaining message is on something. As in, you cannot get the whole message. You will see that you can't get the whole message. Some people must have that experience, maybe using WhatsApp or any kind of thing that you're using, or a normal text message. Yeah? Why is this? It's because it's going through a process in the network, and it's trying to check for what? For errors. Because we have a lot of protocols. The way you send text messages, the way you make phone call, or the way you send email to someone, you understand? They have to follow some protocol. And if there is error, so they have to check if there is error. In that error, they are just checking for, we call it packet information. So if some packet is missing, you understand? If all this packet is missing, they have to discard it. But if those packets, I don't want to explain much, but it's just the same thing like this in compilation. So let's quickly go down. It's like we don't have enough time. And I'm very sorry. So you guys see this yesterday. This is the answer: preprocessor, compiler, assembler. You can see this assembler. You see, after the C language, compile it. He has to send it to what? To assembler language. So which means the purpose of assembler language is to do what? Is to actually send it to what? To convert it to machine language. Normally, if it's some other language, you will not see this one there. You will see process, compiler, then linking, or any other thing that you can see. But this one is actually using two. They compile it from high level language to low level language. But you cannot do that alone. So you have to send it to assembler to now convert it from low level language to machine language before anything can be done. So we can see this also everything is actually explained there. We have preprocessor, compiler. We can always read that up. Are we getting it? So you can see this is the preprocessor. When you run it, it's going to pass through it, the source code, to compile, assembler code, everything will be compiled. After then it return to what? Object code. The link there, it will execute, load that there, it will execute everything. Are we getting it? So let's move on from here. Yes, sir. Hello. Can I continue?
Yes, you can
Please,
continue.
if there's anything on maybe in the message box, I don't know, maybe the link of the site you're using, I don't know, because I joined it not too long. Excuse me? Okay, I was saying that I joined it not too long, so if there's anything maybe you have posted before now, so I would want you to be posted again so that I can. Okay, yes, I'm sorry. We are actually not written any program. I was thinking of writing at least maybe 5 programs for you guys today. Then we are going to give assignments. People are going to do it. You understand? But currently now there's no light here. I don't know whether you guys are getting it, but I'm going to do this. This is exactly 8:54. There is high probability that they might bring the light by 9 o'clock or 9:30. So if they bring the light by 9:30 or before 10, I will let you guys know in the group. If you guys want us to do extra 1 hour, then we cannot join back to the class. But if everybody is tired, then we can pick it up tomorrow. Then we can spend like at least, I want us to write up to 10 programs. So please, tomorrow,